Hi everyone, welcome back to class. It's nice having you all in today's class. Today's class is a revision class, and our focus will be on food and nutritional biochemistry. Food and nutritional biochemistry. In that course, it comprises of food storage, food preservation, food processing, food intoxication, foodborne diseases, proximate analysis of food, the nutritional content, nutritional value, and so on. So now, what we want to do today is to do a general revision of that course, and we are doing that in a twisted form. What I mean by that is that we will try and look at possible objective questions that could come out from that course, and when we look at this question, we will use the question to do a general revision and look at the answer to each question. So welcome back to class. So all my returning subscribers, thank you for your support. I am grateful. It means a lot to me. And if you are coming across this channel for the very first time, I say welcome, and I promise you will enjoy this channel. All we do on this channel is just to learn. So welcome to a safe space where we learn in a fun way. Now, let's start. The following include different methods of food preservation, except A, sorting, B, freezing, C, drying, D, turning. Now, remember when we discussed about food preservation, we said the aim of food preservation is to prevent food spoilage, to avoid food spoilage, and we do that by through different means. We do that through different means. So part of the means where we do that is one, salting. When we add salt to what we want to preserve, the salt will help us to prevent the spoilage of that particular food by reducing the moisture content of it and preventing the growth of pathogens, microbes, disease causing microbes that could be there. So with that, salting is part of food preservative method. Freezing is a process of food preservation whereby you put your food, you will make use of cool temperature, cold temperature, toxic for the microbes, the disease causing microbes that could be there. So freezing is also part of food preservation. Drying is another part of food preservation, another example of food preservation, and what our aim there is to reduce the moisture content of the particular food. So when we expose them to heat, different form of it could be sunlight, it could be the heat that you apply artificially to it to reduce the moisture content and prevent it from spoiling. So that one also is an example of food preservative. The last one is turning. Turning. What are we turning? Turning is not an example of food preservation. So for the answer is D. Now let's move on and check out another example. What is foodborne intoxication? What is foodborne intoxication? Remember when we talked about foodborne intoxication, we said foodborne intoxication is caused by consumption of contaminated food. But this contaminated food, what caused the contaminations are toxins. But for foodborne diseases, it is pathogens such as bacteria, such as viruses, fungi that cause the contamination. But for food intoxication, the contamination is caused by toxins, different toxins, and in this case it could accidentally be added or intentionally added to the food. So now let's check out the options available. We have allergic reactions to certain food, we have nutritional deficiency due to poor diet. We have infection caused by consuming contaminated food. Then D, illnesses caused by consuming toxins in food. So there, the best answer there is D, which is illnesses caused by consuming toxins in food, and that is what foodborne intoxication is all about. Let's move on to the next one. What is a common symptoms of foodborne diseases? What is a common symptoms of foodborne diseases? A, vomiting. B, diarrhea. C, abdominal cramp. D, all of the above. When we discussed foodborne diseases and foodborne intoxication, we talked about their diagnosis, their treatment, their source of contamination, and the rest, and the symptoms. And part of the symptoms that we talked about, and it's actually general to all, is that there will be abdominal cramps. Also, we said vomiting is there, and most of the time sef diarrhea is there. So can you see that all these options are perfect answer to this question? So our answer there is D, which is all of the above. Let's move on. What is the primary purpose of proximate analysis in food science? What is the primary purpose of proximate analysis in food science? Proximate analysis is just the process in determining the nutritional value of food. That's just the summary about everything about proximate analysis. Now let's check out the option. 1, to determine nutritional content. 2, to identify food additives. C, to analyze food texture. D, to detect food contaminants. So definitely the answer there is A, which is to determine nutritional content. So proximate analysis is to determine the nutritional content of food. Let's move on. Which of the following is a common foodborne pathogen? Which of the following is a common foodborne pathogens? Remember, pathogens are disease causing microbes. So now foodborne, and you remember, foodborne diseases are caused by pathogens that contaminate the food. So now let's check out the option. A, we have salmonella. B, E. coli. C, Campylobacter. D, all of the above. All these microbes that we mentioned are all responsible for contamination of food. They could cause disease. So the answer here is D, which is all of the above. All of the above. Moving on. What is the purpose of determining ash content in proximate analysis? What is the purpose of determining ash content in proximate analysis? A, to estimate mineral content. B, to determine protein content. C, to analyze fat content. D, to detect contaminant. Let's start with that D. Proximate analysis is never to determine whether a food is being contaminated or not. No, it's just used to determine the nutritional content of that food. So D is not the answer there. C, to analyze fat content. Proximate analysis contains fat content determination, but it is done separately, so it is not an answer to this question. And that is carried out through the process of using succinase extractor to do that. Now let's move to the next option, which is B, says to determine protein content. Also, it's part of proximate analysis, but protein content is not what you use in determining mineral content. So it is not the answer. Now let's check answer. Let's check the next option, which is A, to estimate mineral content. And that is the essence of us carrying out ash content determination under proximate analysis, to estimate the mineral content that is present there. So the answer to that question is A, to estimate the mineral content. Now, moving on, what is the primary cause of foodborne diseases? What is the primary cause of foodborne diseases? A, consuming contaminated food. B, overheating. C, food allergies. D, none of the above. Number one, food allergy is not a foodborne diseases, and foodborne disease itself is what is caused by eating contaminated food, and these food are contaminated by pathogens, disease causing microbes. So now if we now check our option, B says overeating. Overeating can only cause obesity. That doesn't mean that we have foodborne diseases from overeating. Now then the next option, which is option A, says consuming contaminated food, and that is the answer to that question, consuming contaminated food. So if let's say the question now went further and said, and in the option you have consuming contaminated food with toxins, and in the option also you have consuming contaminated food with pathogens. So you know that your answer will be consuming contaminated food with pathogens, because it is pathogens that will contaminate the food that will cause foodborne diseases. But if a food is being contaminated by toxins, the what we have there is foodborne intoxication. Moving on, which of the following components is typically determined in proximate analysis? Which of the following components is typically determined in proximate analysis? A, moisture content. B, protein content. C, fat content. D, all of the above. We mentioned it earlier, is all of the above. All these content are what we use, are what can be determined through the proximate analysis of food. What is the main purpose of storing food in airtight containers? What is the main purpose of storing food in airtight container? The options are: 1, to prevent moisture absorption. B, to allow free airflow. C, to promote bacterial growth. D, to increase food spoilage. When we were discussing about food preservation, our main aim is to prevent the spoilage of this food, and also to try and slow down the rate at which pathogens will act on that food, or even the rate at which the food could be self-decayed. So, and generally we also say that pathogens, they strive very well moist environment, like in a wet environment. So that was what brought the idea of drying, to remove the moisture content that is there. So going back to this question that is asking us, what is the main purpose of storing food in an airtight container? The answer there is to prevent moisture absorption. To just because if you just put the food, let's say your grains, you just leave them open, in the room temperature without covering, without anything, there will be moisture absorption, because the air in the environment has moisture in it. So definitely we have moisture absorption. So but when we put in an airtight container, then we seal out air from it, which will further help us to preserve that food for longer period. So the answer to that is A, which is to prevent moisture absorption.